Bonsuelo Mathletes. Oh my. Today, we are going to discuss something that will well up love in your hearts. It is the thing that, like, when you wake up in the morning, you say to yourself, Self, if I could do anything today, what could it be? Well, of course, going to mass, that is the greatest thing. That's true. But okay, secondarily, what could you think of? And you think it's obvious. It's intuitively obvious to the casual observer. I would solve word problems. It actually allows you to think. It's not this like rote, kind of like crank through a bunch of calculations. You actually get to think. So let's do it. Let's begin to think. What a novel concept. Okay, in a nutshell, this is it. And I'll go through these in more detail in a second. 1, define variables. 2, write an equation. Guess and check is not acceptable here. This is algebra. This is not guess and check class. You have to solve it with a proper equation. 3rd, solve for check. Okay, so in more detail, what do I mean by this? And make this a part of your being. Absorb it, love it. Okay, so define variable. Define a variable or variables. What am I asking you to do? What's the question asking? Okay, what's the question asking? It's that simple. If I want to know the number of dogs and the number of cats, you have to define a variable for the number of dogs, and it can be a different definition, or it has to be a different definition. It doesn't necessarily have to use a different variable, and then you have to define the number of cats. Okay. Then you write an equation, and how you do this I'll get to as we go through. This is the hard part, okay? What you want to do is look for the most important piece of information. How do you find the most important piece of information? That's what I'm going to go through. Then you solve it. That's pretty straightforward because you've just got an equation at that point. You write your answer in a complete sentence. By the way, for those of you that are unaware of the fact, a complete sentence needs a verb. If you don't have a verb, you don't have a complete sentence. So if you say X equals 20 dogs, if you write with an equal sign, that's not a complete sentence. You have to say, there are 20 dogs. That's a sentence. And then check. And what I mean by check is your answer reasonable? I'm not asking you to go back and check all your calculations, although that's fine too if you want. But basically what I'm asking is this. Is your answer in the ballpark of reality? Like, does it even make sense? And what do? First of all, look at what you're asking for. Back up in your definition. If I want the number of shirts Bob bought, and in your sentence you tell me Bob walked 5 miles to the store. Well, that's not reasonable because you're not answering the question. Okay, what else could reasonable mean? I want the number of shirts Bob bought, and you tell me X equals -7 shirts. That is not reasonable. Okay? So have you answered the question, and does it make sense? Is it in the ballpark of reality, or is it just something that's so weird? Bob bought 5,000 shirts. Maybe strange, but it's possible. Bob bought -17 shirts isn't even possible. Okay? So again, in a nutshell, define your variables, write an equation, solve. Is your answer reasonable? All right, now let's go through these things. And the first problems here, I'm just going to set them up. I'm going to define the variable and write the equation, because after that, it's pretty straightforward. At the end, I'll go through some where we do the whole problem. But for right now, we're just going to set them up. Okay, set up the following problems. In other words, define variables and write an equation. Okay, Snard sold shirts for $3 per shirt. He made a profit of $51 for total expenses were $27. Then how many shirts did she sell? Okay, what do you think is the biggest piece of information there? Okay, what do you care? You haven't defined a variable yet. Don't go looking for the biggest piece of information. We're not concerned with the biggest piece of information right now. We're concerned with what are you being asked, okay? So what's the question? Number of shirts sold. So number of shirts sold. Okay, write the definition first. Let's assign it a variable. There's a reason why I do it in that order. Okay, now we've got the thing we're looking for. Well, Now let's write an equation. Now let's look for the biggest piece of information. And at first, I'm just going to kind of say what it is, and as time goes on, I'll explain more how you look for it if you're not sure. Okay, $3 per shirt, not a big deal. That's like per shirt. A total profit of $51. That's a big piece of information. Okay, so the profit is $51. Now, the thing I'm going to try and get across here is this. I'm going to show you what to do when you don't know what to do. Okay, if you know what to do, just go ahead and do it. So I'm going to show you the long, tedious way to write an equation. Do you have to do it this way? No. At the end, I'll show you what you have to do, like bare minimum. But I'm going to go through every problem as if you don't know what to do. Okay? So, okay, well, assuming you don't know, okay, well, what does profit mean? You take the total money, take the money made or the money taken in, and you subtract the expenses. Okay, the thing I'm trying to get across here is this. When you're having difficulty, describe what it means in English. If you can describe what it means in English, you can eventually get to putting in math. If you don't need to describe it in English, don't. But if you're stuck, what do? Describe it in English. Okay, well, how much money did we make here? I'm not really sure right now, so we'll come back to that. But I know the expenses were $27. Okay, fine. Well, how do you figure out how much money you take in? Well, you sell a bunch of shirts. What do? You take the number of shirts. That's just the number symbol. And you multiply it by the price of each shirt. Okay, fine. Well, do we know those things? And all I'm going to do is keep describing things in English until, we can substitute math in place of it. Okay. So do we know the number of shirts? No, but sort of we know it. It's the thing we're looking for, so let's put X. Do we know the price? The price is $3 per shirt. And there we go. And of course, you can write 3x, but there's your equation. Then you just solve it. Now, there's something I want to mention about solving. So I'm going to stop here, sort of. Okay? But that's all I asked you to do. But if you were to continue this, of course, you could add 27 and then divide by 3. But can we make this equation a little simpler? Yes. Take a look. And this is not that big of a deal, but it's a good habit to be in. Notice there are two terms on the left, and then there's the right-hand side. Is there anything that's in all three of those? Yes, there's a 3. So what can I do? I can divide everything by 3. So I can get rid of the 3. That becomes 9. And that becomes 17. And so what would this become? X minus 9 equals 17. And that's going to be a lot easier to solve. It's astronomically easier, but then 3x minus 27 equals 51. Okay, so what, bare minimum do you need? This equation right here. Well, first of all, you need your definition, and then this equation right here, 3x minus 27 equals 51, before I simplified it. If you've got that, that's fine. I don't need to see this stuff in the middle. It's fine if you do, it's fine if you don't. But that's what you do when you don't know what to do. So, first line, and then the line before I started canceling things, that's fine. But if you're stuck, look for the biggest piece of information. Okay, next problem. Well, blah, 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 blah. You can read it for yourself. Okay, so what are we looking for? How long, time of the one phone call. So we've got time of phone call. You know, you'd be surprised. A lot of people don't give me, they give me an answer, but they're not answering the thing I want. Okay, and we'll call it X. You can call it anything you want. I would stay away from the following variables, though. B, because it looks too much like a 6. O, because it looks too much like a 0. S, I would stay away from because it looks too much like a 5. But other than that, it really doesn't matter what you use. Okay, so what do you think is the biggest piece of information here? Well, I don't know. There are two things you could really pick here. So money left. Let's go for the money left over is 2178. You could actually do this. You could do this with picking the cost of the card is $25. That's fine. By the way, the biggest piece of information doesn't necessarily mean the largest number. It means like the most important thing. Okay, well, how do you figure that out? You have the cost of the card minus the money spent. And then that's 2178. Okay, well, you know the cost of the card, that's $25. How do you figure out how much money you spend? Well, it's the, you make a phone call and it costs you 14 cents a minute, then you want to know the cost per minute times the number of minutes. And that's 2178. Okay, well, do we know the cost per minute? Yeah, that's 14 cents. So it has to be 0.14. Do we know the number of minutes? Well, we have something for it, X, and that's 2178. Okay, fine. Then you just solve it. Again, what do you need? Definition, equation. Now, I am going to show you something with the equation, though. What I would recommend you do, and normally you'd write it underneath this, but I don't have space underneath, is you've got decimals. You've got an equation. You should not have decimals in an equation. So we have to get rid of 2 decimal places, so we'd multiply by 100, and you'd get 2,500 minus 14x equals 2178. And then you'd finish it off. Okay? All right. And again, you know, if you have any questions on any of these, you know, call me up. If you want to see me do this, not call me up, but, you know, ask me in class. If you want to see me do this where the $25 is the biggest piece of information, that's fine. It would basically just be $25 equals the money spent plus 2178. So that's all it would be. It's not really that much different. Okay, number 3. Blah, 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 blah. What are we looking for here? Regular cost of a sandwich. Okay, don't put cost of a sandwich. Why? Because there are 2 costs of a sandwich here. Notice in the first problem, there's only one type of shirt. We only need one variable. It's pretty shirt sold, whatever. There's only one type of phone call here, but there are 2 types of cost here. There's the original cost and then the discounted cost. And if you're not specific in the way you define it, you're going to get lost. So what are we looking for? Regular cost. Of one sandwich. Okay, so what's the biggest piece of information here? Okay, Elvis paid $24. So the total cost, often a total is a good thing to look for. Equals $24. Okay, well, you buy 3 sandwiches. How do you figure out how much You're going to pay, it's the number of sandwiches times the cost of one sandwich. Okay, now I kind of did this on purpose, but that's going to kill you. Why? Because there's a regular cost and there's a discounted cost. And right here, I haven't been specific about what type of cost I'm talking about. Okay? See, what you're going to do probably here is you see cost of one sandwich, you're going to probably put an X. But that's because you haven't been specific enough. Just like in the definition, the regular cost of one sandwich, it has to be the regular cost. Just cost of one sandwich is not good enough. Okay, this is not good enough here. Why? Because there are two types of costs. Okay, so that is not good enough. Did I pay the regular price? No. I paid, I can't speak, but I paid it, the discounted price of one sandwich. Okay? And that's going to give us the 24. Now, how many sandwiches did we buy? 3. What's the discounted price? The discounted price, and again, you don't need necessarily all these steps. It's the original price minus whatever the discount, not the discounted price, but the discount is. Okay. Well, what's the original price? Well, that's what we're looking for, the regular cost of one sandwich. That's X. What's the amount of the discount? It's $6 off each one. Okay? Now, what do you absolutely have to have? You have to have this, and you have to have that. Any of these other lines in between, you do it as you need it. But you know what? Don't ask me, gee, Mr. Liebling, how do you do this if you're not willing to do those steps in between? What are those steps in between? Those are what you do when you don't know what to do. I'm telling you, that's what you're going to do. If you know what to do, fine. Just go straight from the regular cost to the equation. But if you don't know what to do, this is what you do. Express it in English. Until, what if you only need, I don't know, this line right here? That's fine. I mean, do whatever you need. You have to have the first one and the last one. Now, just a quick comment. Again, you'd normally put this underneath. I'm not going to finish this, but what could you do with this equation? Well, you could distribute the 3. That's fine. But wouldn't dividing both sides by 3 be easier? And we have x minus 6 equals 8. And then you can finish off the problem. Okay. This one's getting a little tougher. Pizza Parlor A, you can read it for yourself. That's fine. How many pizzas will result in the same charge for each place? So, we have number of pizzas. Okay, now here's where I need to explain a little bit more about what the most important piece of information is. And if you're not sure on this, ask me, please, because, this is the key. All right, every problem's about something. This one's a lot tougher, actually. Every problem's about something. All right? What's the problem about? What's this problem about? And this problem is not about pizza, believe it or not, okay? And what is it about? This problem is about Pizza Parlor A and Pizza Parlor B. It's not about pizza per se, okay? So this is the biggest piece of information. Figure out what the problem's about, okay? And it's about Pizza Parlor A and Pizza Parlor B. All right, the biggest piece of information will not be about Pizza Parlor A. Make sure you understand that. Pizza Parlor B the biggest piece of information is not about pizza parlor B. Okay, whatever the problem's about, the biggest piece of information has to be about all of that. So if this problem's about pizza parlor A and pizza parlor B, whatever you tell me is the biggest piece of information better be about both of them. So let's go through this problem and just look at what it says. $16. Is that about parlor A and parlor B? No, it's only about A, so it can't be that. The $8. Is that about both A and B? No, it's only about A, so it can't be that. $17. Is that about A and B? No, it's only about B, so it can't be that. $2. Is that about A and B? No, it's only about B, so it can't be that. Well, what else does this say then? What does this problem say about pizza parlor A and pizza parlor B? What it says is they each charge the same thing. So the cost at A equals the cost at B. And, this takes some practice. Okay, it's not like I expect you to get it the first time, but that's what you've got to look for. What's the problem about? And then whatever you tell me is the biggest piece of information has to be about everything the problem's about. Okay, not the little things, but the main thing that the problem's about. Okay, well, how do you find the cost of what A charges? You take the number of pizzas at A, and then the price of a pizza at A. Well, how about at B? You do the same thing. It's the number of pizzas. Oh, I forgot something, didn't I? I just realized that. I apologize, mathletes. Okay, because that's just pizza, but there's delivery. So let's say the cost of the pizzas, all the pizzas, plus whatever the delivery is. And then this would be the same thing. It's the cost of all the pizzas plus whatever the delivery is. And again, I'm going to describe it in English until I can substitute in math. Well, delivery I know. For A, that's 8. And for B, that's 2. Okay, what I don't know is how much do all the pizzas cost? So how much, if I buy a bunch of pizzas, how much do I pay total? Well, it's the number of pizzas times the price of each one. Okay, fine. This will be the same. The number of pizzas at, it's only a B, times the price of each one. Okay, now let's see if that helps. Notice a lot of times a cost of something, a total cost, is the number of items times the price per item. That's a fairly basic idea. Okay, at A, do I know how many pizzas? Well, sort of, because X is the number of pizzas, so I'm going to put X there. Do I know the price of a pizza at A? Yeah, that one's $16. I already have the plus 8. How about the number of pizzas at B? Well, it's the same, because it's the number of pizzas that at each one. What's the price of a pizza at B? That's 17, and then 2. Again, do you need to show me all this? No, you need to show me the definition. You need to show me this equation, and then you'd solve it. Okay? Notice, by the way, you can't divide this one by 2 because the 17 doesn't have a 2 in it. So you just solve the equation. Okay? And again, you're probably going to have to maybe listen to a couple of these a few times. It's not an easy idea to get, but once you get it, it makes them a lot easier. Okay, next. blah, 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 blah. You can read it. How many donuts did each eat? So how many things am I asking you to find here? Notice in all of these problems up till now, I've been asking for one thing. Well, I'm asking for three things here. I want the number of donuts for Elsa. You need three definitions because there are three things you're looking for. The number, you can't just say X is the number of donuts because there are three things I'm asking for. Gordon, and then the number of donuts of what, Reuben? Now, why do I write the definitions first and then put the variables? Okay, try and get away with using as few variables as you possibly can. And in all of these problems, you can get away with one variable. You need three definitions, but one variable. Okay, if you always write X equals on the first one, you're kind of like potentially making your problem more difficult because maybe the first one isn't the easiest one to call X. So if you read this problem, okay, which one would you want to know first? That would easily tell you the other ones. Reuben, Elsa, or Gordon? Okay, well, Reuben ate 4 times as many as Elsa, and then Elsa ate 10 more than Gordon. I don't know. It probably looks like Elsa. I don't know, maybe Gordon. It really depends, okay? Some people will see Gordon as the easiest one, and then you'd want to know that first. Other people will see Elsa. I think I'll pick Gordon first, because if you know Gordon's, then you know Elsa, and then you know Reuben's. Okay? So I'm going to pick Gordon first. Well, who would you know next? Well, Elsa ate 10 more, so that'd be X plus 10. And then Reuben ate 4 times as many as Elsa. So that's 4 times the entire value of what Elsa ate. Okay? That's why I'm going to solve it. That's why probably most people will see it. But you know what? Some people might do this. I'm going to do this off to the right. Some people think, well, it's easier to say Elsa. I know that first. And then Gordon would be X minus 10. And then Reuben will be 4 times Elsa. It's a perfectly good way to do it too. You have different definitions, and your equation will look a little different, but you can still get the final answers the same, okay? So either one of those, either the ones on the left, which are the ones I'm going to use just because I only want to do one, or the one on the right, it doesn't matter, okay? So I'm going to get rid of the ones on the right here, but those are perfectly good. Some people might even say they're better. Okay, so what do we know? The total donuts. Again, what's this problem about? It's not about donuts. It's about Elsa, Gordon, and Reuben. Okay? So whatever you tell me is the most important piece of information has to be about all three of them. Not Elsa, not Gordon, not Reuben. It's got to be about Elsa, Gordon, and Reuben. Okay? So the total donuts is going to be what? 80. And what's that? That's Elsa's donuts plus Gordon's donuts. And I don't mind you using when I say use English, I don't mind abbreviations. Just get the idea across. Plus Reuben's donuts. And you don't even need to write this at all if you don't need it. Again, I'm showing you what to do when you don't know what to do. That's going to be 80. Okay, well, what's Elsa's donuts? That's X plus 10. What's Gordon's donuts? That's X. And what's Reuben's donuts? That's, you can put 40X plus 40 or just 4 times X plus 10. And then you solve the equation. Okay? So what do I need to see from you? 3 definitions, not 3 variables, 3 definitions, and 1 equation. The stuff in the middle, if you need it, do it. If you don't, that's fine too. Okay, go through a couple really quick here, and then we'll go on to the actually solving an entire problem. The perimeter of a rectangle is that. What's the length if the width? Okay, so x equals, sorry, I should not be doing that. I should define first what we're doing. So we're looking for the length, and we'll call it x. What's the biggest piece of information? Perimeter equals 338. Okay, well, how do you find the perimeter of something, of a rectangle anyway? So it's 2 times the width plus 2 times the length. So you have 4 sides. Okay, do we know the width? Yeah, the width is 72. Do we know the length? The length is x, and that's 338. Pretty straightforward. You need the definition, you need the equation. What could you do with this? To simplify it, divide everything by 2. You don't have to right now, but 72 plus x, and what's that divided by 2? Let's see, 2 goes into 3. It's 13, 6 times 18, 9. Okay, and that'll just be a little easier to solve. Okay, I'm going to blitz through these pretty quickly. What are we looking for here? What's the length? Okay, now, I didn't tell you what the width is directly. And we're not looking for it. But if you wish to put a definition for it, don't put tons of definitions, though. What are the only extra ones you're going to put? Something that's important and unknown. Is width important to perimeter? Yes. Is it unknown? Yes. So you may or may not, and it's totally up to you, define also the width. And what's the width? It's 118 less than the length. That's totally up to you whether you want to define that or not. Okay? So now what? We have the perimeter equals 448. What's that? 2 times the width plus 2 times the length equals 448. And do we know the width? Well, whether you've defined it or not, you'd put x minus 118. And then 2 times the length, and length is x. And again, what you can do to simplify this equation is just divide both sides by 2. Again, what do you need? You need the definition of the thing you're looking for and your equation. Okay, last one. Find the width, which is x. Okay, here, area is 99. How do you find area of a rectangle? Length times width Okay, what's the length? Oh, sorry, the area is not, I apologize. The area is not 99. The area is 8712. Okay, so what's the length? It's 99. And what's the width? X. And that's 8712, and then you just solve it. Okay, again, what do you need? Definition, thing you're looking for, and then the equation. Okay, and you can spend as much, pause your screen if you need to copy any of this more down, any of this down. Review the me talking if you need an explanation. And if that doesn't do you any good, then ask me, okay? Now, let's go through some problems and actually solve, finish it off. Okay, so first of all, you can read the question there, fine. So what are we looking for? A single ticket each location. We're not looking for one thing. Why? Because there are two things. So there's a single ticket cost at, well, let's just say the Coliseum. Sorry. And then the single ticket cost at Dodger Stadium. Okay. Now, which one do you want to know here first? You could do it, it doesn't really matter in this particular problem. Probably you'd want Dodger Stadium to be the first, and then x minus 5 to be the Coliseum. That's the way I've kind of expressed it. But if you do it as x being the Coliseum and x plus 5 being Dodger Stadium, that's fine. It's not that big of a deal. I'm just going to pick this because that's what's the way the problem's written. Okay, so what's this problem about? This problem's not about tickets, okay? It's about the Dodger Stadium and Coliseum. So whatever is the biggest piece of information, it must be about the Coliseum and Dodger Stadium. So what does it tell us? Well, the 100,000 Coliseum tickets is not about both places, so that's not it. The 60,000 Dodger Stadium tickets is not about both places, so that's not it. But the $1,100,000 is money for both places. So total money equals $1,100,000. Okay, well, how do you find a total? It's going to be usually this, not always, but the sum of two things. Well, what would be the two things we'd be adding up? We'd be adding up the Coliseum money. And again, you can use abbreviations and symbols and stuff. It's supposed to be a dollar sign. It didn't come out too well. Plus the Dodger Stadium money. Okay, fine. Well, but we don't know how much money was at the Coliseum, and we don't know how much money was at Dodger Stadium. So let's say you sell a bunch of tickets. Okay, to find out how much money you make, you don't want to sit down and count all the money. As I've kind of briefly mentioned before, how do you find the total amount of money when you sell a bunch of something? You take the number of items times the cost per item. So we have at the Coliseum the number of tickets times the price of one ticket. At the Dodger Stadium, we have the number of tickets times the price of one ticket. And that's 1,100,000. Okay, fine. Do we know the number of tickets at the Coliseum? Well, yeah, it's 100,000 tickets. Do we know the price of a ticket at that 100,000 is at the Coliseum. Do we know the price of a ticket at the Coliseum? Well, we have an expression for it. We have x minus 5. Keep in mind always what you're looking for. Okay. How about the number of tickets at Dodger Stadium? Well, that's 60,000. And the price of a ticket is X. Okay, there you go. So now we solve it. Now, there's something I want to point out, though. I mean, you can solve this, but is there something we can do to make this like a little easier? Well, notice every single term, and there are two terms on the left, and then there's just one thing on the right. Every term has an extra 10,000 that it doesn't really need. So that's the initial equation. I'm going to just divide each side by 10,000. So what happens? I get rid of 10,000 out of each one. And what I get is, and actually I could divide out a 2 also, but it would be better to divide out the 2 also, but I'll just put 10 times x plus 5, x minus 5 plus 6x equals 110. Or if you divide by 2, you get 5 times the quantity x minus 5 plus 3x equals 55, which is even easier, but I'm just going to do this. Okay, so we get 10x minus 50 plus 6x equals 110. Okay, so find something to get 16x equals 160. And then I'll finish it up. I apologize for the lack of space here. Okay, so x equals 10. So now let's write a sentence. Dodger Stadium tickets cost $10 and Coliseum tickets cost $5. Okay, that's how I want to see the problem. What do I need to see here? First of all, I need to see the definition. Next, okay, I need to see the equation. What about these 3 lines between the definition and the equation? Write them if you need them, don't write them if you don't. But don't come to me and say, I don't know how to do this if you're not willing to write things out in English. If you don't need to, don't. Next, I need to see the work somehow, maybe not every line here, that shows the solution, and then I need to see the sentence. Okay, that's what I need to see so that I can say, you know what you're doing. All right, next one, 2 cars leave the cities, blah, 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 blah. Okay, what's the speed of the blue car? Blue car. X equals not the speed, because there are 2 cars here. So you have blue car speed. Okay, that's all I'm asking for, all right? Now, may you also define the red car speed? Well, is the red car speed important to this? Yeah, I'd say so. So you may define it if you want, but I'm going to put a little line here because it's unnecessary. I'm not asking you to find it, okay? So what would the red car speed be? Well, let's see. The blue car goes 14 slower than the red car, so the red car goes faster. But I'm not going to call X the red car because I'm not looking for that. I want X to be at least one of the things I'm looking for. Okay, if I can show you something back up here. You know, when we were talking about these 3 persons, I was looking for all 3 things on the number problem 5. So it doesn't matter which one I call X. But down here, I'm only looking for the blue car, so that's the one you want to call X, okay? All right, so now what's the biggest piece of information? First of all, what's this problem about? This problem is not about distance, this problem is not about speed, and this problem is not about time. Okay, so what's it about? It's about 2 cars. It's about a blue car and a red car. So whatever you tell me, it can't be about the blue car. It can't be about the red car. It's got to be about the blue and the red car. So, like, if we look at this, is this 320 miles apart, the blue and the red car? Yeah, because the 2 cars are 320 miles apart. The 14 miles per hour isn't really about both of them, and the 2 hours is really not about both of them. Okay, the 14's I'll come back to that. You could say the 14 is about both of them because the blue car goes 14 miles per hour slower than the red car. So yeah, okay, that's about both of them too. But I'll come back in a little bit and tell you why I'm not going to pick that one. So we have total distance is 320. Okay, what's the total? It's the sum of the two things. So we have the blue distance plus the red distance equals 320. Okay, well, how do you find distance? Well, you should know that distance equals rate times time. Okay, it's a pretty standard idea. You know, like if I drive my car 2 hours and I go 60 miles per hour, I'm going to go 120 miles, all right? So we have rate or speed times time. And again, do you really need to write all this? No, not if you know what you're doing. If you know what you're doing, go ahead. Okay, so do we know any of these things? See, we didn't know the blue distance and we didn't know the red distance. That's why we needed to describe it in English. Okay, so do we know the rate of the blue car? Oh, yeah, that's x. Okay. Do we know the time of the blue car? Well, they both leave at the same time and they both meet in 2 hours, so the time of the blue car would be 2. Okay, how about the rate of the red car? I didn't, whether you defined it or not, it's going to be x plus 14. And the time is 2. Okay, what can I do to simplify this? Well, yeah, you can distribute the 2, but wouldn't it be easier just to divide the 2 out? So we have x plus 14 equals, remember, divide both sides by 2, 160. So then we bring the 14 over and we have 2x equals, what will that give me? 146. And then divide by 2 and we get x equals 73. So the blue car goes 73 miles per hour. Okay. Now, this is going to be kind of the culmination of all of it. Why did I pick the total distance to be the biggest piece of information? Okay. Here's the piece of information you want to pick. As I've said before, it has to be about both things. It has to be about the red and the blue car. But you don't want to pick the type of thing that you're being asked to find. So what do I mean by that? I'll get more into this in the next problem. Okay. There are two. So I'm going to scribble a bunch of stuff down, but just listen. You don't need to write this down. You could say there are two big pieces of information here. Okay, so again, you don't need to write this down. We're done with this problem. Okay, the first is total distance is 320. Fine. Is that about the blue and the red car? Yes. How about this statement? The blue car speed is 14 slower than the red car speed. Okay? Now, there's something that kind of came up there, just so you know. A verb in English always translates to always translates to an equal sign in math. So that statement, the blue car goes is a verb, so that's why it's equals 14 less than the red car speed. Okay. Now, someone says to me, well, that's two big pieces. Both of those are about the blue and the red car. That's correct. So how do you know which one to pick? This is kind of the opposite of what common sense would tell you. Okay? And if sometime you want to ask me why this is, I'll explain it. But right now, I just kind of want to tell you what to do. If you're not sure which one to pick, look at what you're being asked to find and go back to your definitions. You're looking for speed. Therefore, you get rid of speed and you use the other one. That's kind of like the opposite. You'd think, oh, I'm looking for speed. I want to use the statement about speed. No. If you've got two, of course, if you only have one big piece of information, you just use that. But if you have two big pieces of information and you're not sure which one to pick the one that's not about the thing you're looking for. Okay, so I'm going to get rid of that, and let's take a look at this next problem. Last one. Okay. Find the distance. You can read it for yourself. What are we looking for? Find the distance that a car travels going. Okay, so we're looking for the distance that the car travels. And if you put that, you're wrong. Because I'm not looking, that would be like the total distance. I misspelled distance also, but that'd be the total distance, okay? I want to know the distance that the car travels while going 60 miles per hour. That's what I'm looking for. Okay, and that's all it says. Okay. So what else is happening here? Is there anything else happening that's important? Yes, but so you don't need to define it, but we can. It's up to you. And what's the other thing happening here? You have the distance the car travels going 40 miles per hour. Okay. Well, find the distance that the car travels going 60 if the total distance is 210. So, well, if its total distance is 210 and the distance of one part of the trip is x, what's the distance of the next part of the trip? 210 minus x. It's the total distance minus the part. Okay. Now, don't write anything else down, okay? Let's look for what this problem's about. This problem is about a car going 60 and a car going 40. It's not about distance, it's not about rate, and it's not about time. It's about a car going 60 and the same car going 40, okay? Now, so whatever you tell me is the biggest piece of information, it's got to be about both the car going 60 and 40. Well, okay, let's take a look at the 60 miles per hour. No, that's only about the car going 60. Let's look at the 210. Is the 210 about both the 60 and the 40 together? Yes. So you could say, don't write this down though, total distance is 210. Fine. Okay, the travel and the time that the time that the car travels 60 is 1 hour less than the time that the car travels 40. Is that about both the 60 and the 40? Yes. So what's that? You got the time at 60 is, remember, a verb is an equal sign, 1 hour less than the time at 40. Okay? Both of those, total distance is 210, time at 60 is the same, is 1 hour less than the time at 40. Those are both about the car going 60 and the car going 40. So which one do you pick? Again, it may seem like the opposite of what common sense tells you, but look at the thing you're looking for, distance. So I want to pick the one that's not about distance. So I'm going to get rid of this one. Okay? All right. So that's my biggest piece of information. The time at 60 equals the time at 40 minus 1. And again, you may need to listen through this a few times. You may need to just like pause it and look at it. I think probably listening to it is going to be necessary also. But if you have a question, ask me. Okay, so now, well, do I know the time at 60 or the time at 40? No. So how do you find time? Remember, distance equals rate times time. So what's time? Time is going to be distance divided by rate. Okay, and again, we keep describing it in English until you can substitute stuff in. So let's see, do I know this? Do I know the distance at 60? Oh yeah, that's x. Do I know the rate at 60? Yeah, it's 60. Okay, do I know the distance at 40? Well, yeah, up here, even if I hadn't defined it, that's 210 minus x. And do I know the rate at 40? Well, yeah, that's 40. And then minus 1. Now, let me point out something to you. Describing it in English breaks the problem down into parts. Notice, I didn't have to just write some grandiose equation right off the bat. If you can do so, fine, be my guest. But what it did is I only had to find the distance at 60, and I could do that. Then I only had to find the rate at 60. I could do that. Then I only had to find the distance at 40. That's a little tougher. I'll come back to that. And then I had to find the rate at 40. Okay, I could do that. So really the tough part here is the distance at 40, okay? Now, but notice what I've done is if you've written all this out, but you just haven't done this part yet, well, it'll be easier to find that one thing, the distance at 40, if you've already written the rest of the equation, rather than trying to do that at the same time you're writing the rest of the equation. You're breaking, it's just like any time you have a project, you break it down into parts. So yeah, saying the distance at 40 is 210 minus x is difficult, but it'll be easier if you've already done the rest of it. Okay, now what will we do at this point? Multiply and get rid of, again, it's an equation, there are fractions, you want to get rid of fractions. So what's the lowest common denominator for 60 and 40? It's 120. If you did like 240 or something like that, it's okay, but the easiest one is 120. So I'm going to multiply everything by 120, every term. And notice on the right here, there are two terms. So I'm going to cancel the 60 and the 120 to give me 2x. I'm going to cancel the 40 and the 120 to give me 3 times 210 minus x. And then this is just 120. Okay, now it's not that hard. So we have 2x equals 630 minus 3x minus 120. So I'll bring the 3x over, and I'll take the 620 minus 1, so that would be 510. And then divide by 5, and we'll get 102. So now let's write the answer. So the car travels 102 miles going 60 miles per hour. Okay, that's a lot. I've gone through a lot here, but I just figure that the more examples I go through, the more it'll help you. Again, start at the beginning, and these problems get progressively more difficult. I don't just start with this one because obviously this is the hardest one. But if you have any questions, ask me. Bonsuelo, it's been great. Isn't this great? Don't you just say to yourself, gee, I hope we can do more of this next time. I know I do. Bonsuelo, everybody. Have a great day.